1 2 1 2 1 2 1 2 1 2. Woo!
Hello guys, and welcome back to this one. So today we are going to be getting into the third leg before the complexity, which is the debugger 2 illustration of the merge brute force file merge sorted files basically. So we are going to be looking at the optimized code, and we see how the values now go through it, and then we see how we end up printing out our fully sorted single file. So yeah, let's get into it. So yeah, our file as usual, we've seen this twice already. So we step into it, right? So we have a mini heap has been established, and these are the file values, right? Let's just put that out so we can see it here. So these are the file values, and then we say, well, now we get into the for loop. So basically we could see now that we are trying to populate using, so we're going to see for files in length files. So basically this length is what? Length of these files is 3. So we're going to start for all the files. So 0 1 2, we're going to be going through all of them, and if there's any of them that is greater than 0, which is obviously we have that all of them are greater than 3, we check we say heap push. So we are basically pushing into the heap the file at the index of 0, which is for all of them the first one, right? And then we are saving the file index, which is, these are the files and these are their indexes, and they also have their own sub indexes, which are 0 and 1. So basically we are saving that sub index and then the file index over here. So that's what we are going to be doing with the push. So let's just run through that. So we see that 1 comes in the mini heap, and then we have 3 coming in the mini heap, and then we have the last guy, which is 7. So we can see that we now have the first 3 guys in the mini heap with their tuples showing their location. This is the location of this guy. That's the 0 file index and the sub index of 0. This one is the file index of 1 and the sub index of 0. All of them will have the same sub index because you're popping out the first guy. Now we go into the while loop now, where we get serious with our algorithm, and then we say while this mini heap exists. So basically we go into it and we pop out that first value to see that 1 should get popped out, and value should now become a thing. So let's just go through that. So we see value become a thing, which is 1. We see the file index should be held as 0. So basically we are holding all this value, and then we're also holding index, which is what? This thing, which is 0, right? So having said that, right, what's it called? Now having said that, we say print value equals to 1, next index equals to 1 plus 1, right? Now having said that, we are here, and basically we've extracted all the values. Now what do we want to print? We want to print 1, which is value equals to 1, right? Now we go ahead to say now that next index equals to next index plus 1, index equals to 0, right? So this is next index plus 1, so we are going to be raising it. So next index will now hold a value. Let's step over that, and we'll see next index on our timeline right here. So this next index, right? So we have it in our value, and we are holding it as 1. So now we go through, we now say if next index is less than length of files, right? Basically the length of the file is 3. So if next index is less than that, next index is 1, the length of this file is 3. So we can know that that condition is met, that we should push a file from that next index, right, of the, so basically we are saying this is the node that we are working with right now. The guy that we extracted the value, the index, and the file index from. So now we've increased next index to 1. So we're now saying for this guy, let's go to now 2, and then let us add that. So because file at index of 0 and index of 1 is what going to return us 2, right? And then we're going to store that and store that value again. So yeah, let's now see how that makes sense. Now we go back to the mini heap. Now we can see that what we have here in the first index now is now what 2 0 and 1. Well, I mean, while the other guys remain. So we will see that uh, the 1 has been popped out. So we're going to check which one is the least again. Which one is the is at the tip? It's at the tip of the heap. You see that is the 2. So we move on because that's what heaps do. They bring the lowest value to the tip of the heap, right? So mini heap has popped out that guy again. Has popped out the node at this root. Now we have 3 and 7 left. So we now go ahead to now pop out 2, create next, go through this guy and update it again. So now we have 3 coming from 3 now is the least, but we now have 5 coming from the 0 index file. So we now go ahead. 3 is now the least because what's the advantage? The heap is helping us, identify which one is going to be the least before we even do anything. So this time around we're going to pop out 3. Now 3 is out, 4 comes in. 4 comes in from this second list or from the 1 index list. And once it comes in, what do? We have 4 we have 4 at the tip immediately because that's what came in and that's the least amongst the lot, right? And then we also continue. So that's just the algorithm. The heap helps us immediately, identify the list of the 3 lists, the list, that's LEAST, of the 3 lists, that's LIST, of the 3 tuples. Okay, that makes sense. The list tuple in the list, right? The list here comes in. But yeah, so you understand what I'm saying, that it just gives us the list value from these tuples, right? And yeah, we continue to do that and keep popping in from the one we've just been attended to from. And by doing that over and over again, we'll get to a point where the one is exhausted. What we now have will just be things from this first guy has been exhausted. We now have things from these 2 lists, and they are going to now, the heap is going to continue doing its work, which is what? To ensure that it gives us the least one, and then at some point 10 is now left over because this is now we still have 9, so we can move over 9, and yeah, 9 is already has now been popped out. We now have 10 in our value, and we get done, and now we're already done with our stuff. So we can see what's happening. What's happening is that the heap has the ability to immediately return the least value amongst the lot. And because of that, and look at how it does that, most importantly, how it does it with a log of n time, rather than having to go through the list, right? It's be able to filter immediately and give us the least value. Basically, is what the advantage is with heaps in this scenario, and we will look into the complexity next to see where the advantage is over the brute force. So muchas gracias. See you on the next one. Bye.